In the last lecture, we studied the LVDT and strain gauge. Now, in this lecture, we study thermocouple. So, thermocouple is a transducer which converts heat into the EMF. So, now here how the diagram, now here for thermocouple need to take two different types of dissimilar metals, and now here I am taking one metal and another one. So, this is another conductor. So, now as a conductor or semiconductor both can be used. Now, here both the ends are joined together, then it is forming the two junctions. If the two junctions temperatures are same, the potential difference here the potential developed in these two junctions are same, thereby no current flows in this loop. So, now if the potential difference is different, now here this junction, this is called as a junction 1 or cool junction or measuring junction or hot junction. This is a junction 2 called the reference junction or cool junction. Now, here we are maintaining the room temperature or 0 degree temperature. Now, here if the temperature, we change the temperature of this junction, now here by using, now here if I am changing the temperature of this junction, then if the two junctions temperatures are different, then the potential developed in this is different, thereby what? Because of this potential difference, so now current flows in this. That current or EMF can be calculated by using the meter. Now if I connect one meter, millivolt meter, then this voltmeter will read the EMF. Now like this temperature is, now here the reading is directly proportional to this temperature. So it is converting the temperature into the EMF. This is about the thermocouple. Now thermocouple is the example for the, now directly it doesn't require any external supply. So this is the active thermocouple, active transducer. And the next one is instrumentation system. Now here this is the instrumentation system. Now in the instrumentation system, from the sensing, so how the physical quantity is sensed and how it is going to be recorded or how it is going to be stored, that we are going to study under this instrumentation system. Now if you see here the physical quantity is sensed by using the primary sensing element. Now if you see the transducer block diagram, it is having the two blocks. The first block is sensing element. First block is having the sensing element which will sense the physical quantity, and the output is a non-electrical quantity which is applied to the transduction element. Now this transduction element will convert this non-electrical quantity into electrical quantity. Now this is about this is the block diagram of the transducer, which is having the sensing element and transduction element. And now in every transducer, so both the elements are not required. Sometimes the transduction element itself, it will sense the physical quantity and converts into the electrical quantity. Just now example we have seen the thermocouple. Thermocouple directly it is sensing the heat and it will converting into the EMF or voltage. Now here in that thermocouple there is no requirement of this sensing element. A transduction element itself, it is converting this heat to the electrical quantity. Now but few transducers directly can't generate the electrical quantity. So now here the sensing element we can call it as a primary sensing element, and a transduction element we can call it as a secondary sensing element. Now here if you see the primary sensing element means, so it will sense the physical quantity and it will give the non-electrical signal, and after that variable conversion element. Now here it will convert the now here it will generate the signal in the form of analog, and here the variable conversion element, mostly it is a secondary sensing or secondary transducer, which will convert the non-electrical quantity into the electrical quantity, or if any analog signal is there, that will be converted into the digital. So now here the variable conversion element will convert the analog to the digital or non-electrical quantity to the electrical quantity. Most of the cases, this primary sensing element is the primary transducer, which will convert the physical quantity to the non-electrical, and the variable conversion element is a secondary transducer, which will convert the non-electrical quantity to the electrical quantity. And here the variable manipulation element, now after the, sensing the physical quantity and converting into the electrical, that electrical signal amplitude or that magnitude will be very, very less, in the order of micro or millivolts. That should be amplified, the signal strength should be increased. That can be done in the variable manipulation element. Now here the signal strength will be increased, or some filtering should be done. Those things will be taken care of by this variable manipulation element. Now after that, now here data transmission element. Now all the transducer doesn't require this data transmission element, but few transducer requires the data transmission element. For example, if we try to measure the furnace temperature, now at the same place we can't read the data, or we can't manipulate the data. So need to bring the data to some other area to record or to monitor the readings. For that we need some transmission lines and some telephone lines. Those cables are called the data transmission elements. So it is transferring the data from one place to other place. So this is about the data transmission element. And the last one is data presentation or controlling. Now here now it will display the data, or it will record the data, and sometimes after getting the output value, again we need to control the device. We need to send the feedback signal to the input. So for that also we will use this now in this block, now in this section, that will be done. So data recording or data storage or display can be done in the data presentation or controlling. Now this is about the instrumentation system. Now with this we finished the first part of the unit 5. In the next part we will study the data converters. Thank you.